graphing inequalities and solving two-step inequalities. To begin with, let's review what we know about inequalities. When we use a solid dot, it includes the number. When we use an open dot, it does not include the number. When we use an arrow pointing to the right, that indicates greater than. An arrow pointing to the left indicates less than. Here are 4 examples. X is less than 4. We start at 4. It has an open dot because it does not include 4, and it points to the left. X is less than or equal to 4 is the exact same graph, but since it's equal to 4, it has a solid dot. Here we have x is greater than 4 and x is greater than or equal to 4. Again, the exact same graph. The only difference is the top one is not shaded in because 4 is not part of the solution set. One thing to keep in mind when we're working with inequalities as compared to equations, the number of solutions is infinite. Not just one like in an equation, we have an infinite number of solutions when we work with inequalities. So let's begin by graphing some inequalities. Go ahead and do the first one. Graph x is greater than 7. All right, to begin with, we start on the number 7, 5, 6, 7, and it's an open circle because it's x is greater than 7, does not include 7, and since it's greater than, the arrow points to the right. Go ahead and graph x is greater than or equal to -5. We start on -5, and since it's equal to, we shade in the dot. And since it's greater than, it points to the right. Go ahead and graph x is less than 2. So we start on 2, and we have an open dot pointing to the left. Go ahead and graph x is greater than 4. We start on 4 with an open dot pointing to the right. All right, write the inequality for each graph. Go ahead and do those 4. So we're starting on 7 here. It has a closed dot and all the numbers are greater than. So x is greater than or equal to 7. Here we're starting at 0. All the numbers are greater than, and we don't include 0, so x is greater than 0. Here we're starting on the number -10. It has a solid dot, and all the numbers are smaller than that, so x is less than or equal to -10. Here we started on number 11. We have an open dot. All the numbers are less than, so x is less than 11. Solving two-step inequalities. We've already learned how to solve two-step equations. Let's apply these steps to solving inequalities. But they're not equations, they're inequalities, so there are going to be some differences. And how is it going to be different? First, at times you may need to switch the direction of the inequality. And the solution to an inequality is also an inequality. And an inequality has infinite solutions. So when we're solving inequalities, we need to remember the rule that we flip the sign when we multiply or divide both sides of the inequality by a negative. So we flip the sign when we multiply or divide both sides of an inequality by a negative number. So let's go ahead and try this one together here. 6 is less than or equal to 4x minus 6. So we're trying to get x by itself. We're going to work this just like an equation till we get to the last step. So we're going to isolate x. So we're going to add 6 to both sides. 12 is less than or equal to 4x. Then we're going to divide by 4. So at this point, we have a 3 here and an x here. Before we determine the sign, we want to ask ourselves, did we multiply or divide by a negative number? Well, we divided by a positive 4, so we keep the same sign. So 3 is less than or equal to x. We like to have the x on the left side, so we're going to rewrite this, and when we rewrite it, we flip the sign, because if 3 is less than or equal to x, then x is greater than or equal to 3. Once I have it with my variable x on the left side isolated, I'm going to go ahead and graph it. I'm going to start on 3. And since it's equal to, it's solid, and greater than, it goes to the right. So we're going to name 4 solutions for this inequality. So remember, inequalities have infinite number of solutions. So we can pick any 4 numbers. I could pick the number 5. I could pick the number 18, 203, 1,743. Any number that's greater than or equal to 3 is a solution of this inequality. I picked integers here, whole numbers. It could have been a decimal. I could have picked 7.7 repeating. All right. Number 2, negative 7x plus 11 is greater than 67. Again, we're going to work this just like an equation. So we're going to isolate the x by minusing 11 on both sides. Minus 7x is greater than 56. Now we're going to isolate by dividing each side by negative 7. So on the left side, that leaves me x, and on the right side, that leaves me negative 8. Now before I look at the sign, let me go back and say to myself, did I multiply or divide by a negative number? Well, I divided by negative 7. So yes, I did divide by a negative number, so I need to flip the sign. Instead of being greater than, now it's less than. X is isolated on the left, so now I can go ahead and graph. I'm going to go find negative 8 on my number line. Negative 5, negative 6, negative 7, negative 8. And it's an open dot, and X is less than that. So to name 4 solutions that are less than, that represent x is less than negative 8, it's going to be any of these negative numbers that are less than negative 8. So negative 100, negative 75, negative 20.2, and let's say negative 18. Okay, our final example, x divided by negative 3 plus 8 is less than or equal to 7. So we're going to solve this just like it were an equation. So we're going to isolate x. So first we need to minus 8 on both sides. So let's do that. We're going to minus 8 on both sides. Now we have x divided by negative 3 is less than or equal to negative 1. So I'm going to get rid of the denominator by multiplying each side by the denominator. So I'm going to multiply this side by negative 3 and this side by negative 3. So when I multiply this side by negative 3, it just leaves me x. That's why I did it. And here I get a positive 3. Now before I write my sign, I'm going to say to myself, did I multiply or divide by a negative number? And I did. I multiplied each side by negative 3. So I need to flip my sign. And since the x is isolated here on the left side, I can go right to my number line and graph. I'm going to start on the number 3. 1, 2, 3. It's a greater than or equal to, so it's a solid dot going to the right. Now to name 4 solutions, any 4 numbers bigger than 3. So I could even say 3.01. Is that bigger than 3? Yes. How about 7? How about 23? How about 2,148? Any numbers that's greater than or equal to 3 is a solution of this inequality.